Hi there, this is Mrs. Hall. I wanted to answer one of your questions about number 10 on the 7.3 study guide. On the 7.3 study guide, we're talking about negative exponents and how to shift a term from the numerator to the denominator. And so here, if we have a to the n and it's in the numerator, I can take the term a to the n and I can put it in the denominator by changing the sign of the exponent. In the same way, if I have a term that has a negative exponent in the numerator, I can take that term and put it in the denominator and it changes the sign of the exponent. So a to the negative n becomes a positive 1 over a to the n. Change the sign of the exponent to shift a term between numerator and denominator. So here is problem 10. And so the first thing that I did was I just split it up so that we could look at those like bases. I wouldn't normally do this in my work, but for explaining it, I wanted to show you your like bases of m, your n's, and your p's. And so we do have 4/12 that would reduce to 1/3. And if I look at my m's, I am going to shift. Normally, how you want to think about it is I want to shift the smaller exponent to the larger exponent. That will help to avoid any negative exponents in your final answer. And so I see the smaller exponent is m to the negative 2, and so I would like to put that in the denominator. And so that becomes a positive 2 in the denominator, and then I can cancel that out. The same way I do 4 divided by 4 equals 1. Well, m to the negative 2 divided by m to the negative 2 is also 1. I have moved it to the denominator. And so here, where is my larger exponent? I have n to the 1 and n to the negative 5. N to the 1 would be the larger exponent, and so I'm going to take my negative 5 and shift it to the numerator by changing the sign of the exponent. And then I can cancel that out. Here I have p cubed over p to the 1 power. And so I would like to move my p to the 1 to the numerator. So if it's a positive 1 in the denominator, that means that it will be a negative 1 in the numerator. And so what do I have left? In the numerator, we have a n to the 1 plus 5. That would be adding exponents, n to the 6th. And then p to the 3 minus 1 would be p squared. In the denominator, I still have a 3. And then I have an m to the 2 plus 2, which is m to the 4th. And so that is the short and sweet of how I think about exponents. But not everybody thinks about them that way. Again, in mathematics, we know there are many different ways to think about a problem. So let's say that I have the same problem, and I wanted to move all of my variables to the numerator. So we would still reduce our 4/12. So if I already have an m to the negative 2 in the numerator, and I want to shift my m squared to the numerator, that means that if it's an m to the positive 2 in the denominator, it would be an m to the negative 2 in the numerator. I would change the sign of the m squared, and it would become m to the negative 2. Next, I have n. And then I would like to bring to the numerator n to the negative 5. So if it's n to the negative 5 in the denominator, it becomes n to the positive 5 in the numerator. In the same way, I have p cubed. And then I have p to the 1 power in the denominator, which makes it p to the negative 1 in the numerator. And I have 1/3 out front here. And so combining my terms, I have 1/3. And then m to the negative 2 times m to the negative 2 means I'm adding my exponents. So that becomes m to the negative 4. I have n to the 1 times n to the 5th, and that becomes n to the 6th. P cubed times p to the negative 1 exponent, so that's 3 minus 1 for p squared. Now again, in algebra, we never leave negative exponents. We always like a final answer that has positive exponents. And so I see m to the negative 4 has a negative exponent. So I'm going to put m to the 4 in the denominator to change the sign to a positive 4. I still have a 3 in the denominator. And then I have n to the 6th and p squared. So there are many different ways that we can think about exponents. Most of the time, I try to do the problems to avoid negative exponents. And I can avoid those negative exponents if I just always think about shifting the smaller exponent to the larger exponent. if I do end up with negative exponents, well, I know how I can take care of that. I hope that this helps. Bye now.